Intermediate Algebra, I'm at 1033. This is Chapter 8, Section 1. First part of this section deals with solving quadratics algebraically. Remember that a quadratic is a problem that has a variable to the second power, and that's the highest power they have. So in this first problem, we have x squared equals 50, which we take the square root of both sides. Remember the golden rule in algebra, what I do to one side, I must do the other. Also remember now that when you take the square root of a value, you have a plus or minus there, because we don't know whether it was a negative or a positive that was placed in here. We simplify the square root of 50 by doing 25 times 2. Square root of 25 is 5, so we get our final answer of x equals plus or minus 5 square root of 2. In the second example, here we're dealing with imaginary numbers. We have 2x minus 5 in parentheses squared equals negative 16. Normally, if we didn't have imaginary numbers, we would say that there was no solution. Because by rights, in real numbers, we can't take the square root of a negative value. But because we're dealing with imaginaries, we can deal that. So first thing we do is take the square root of both. Square root of 2 minus 5 squared becomes 2x minus 5. Square root of negative 16, we bring the I outside, take the square root of 16, we get plus or minus 4i. Now it becomes just a two-step algebra problem. Add the 5 to both sides, we get 2x equals 5 plus or minus 4i. Divide by 2. To be honest with you, I'll take either form of this answer. I'll take the 5 plus minus 4i over 2, or if you want to split it up and bring the 2 underneath the 5 and the 2 underneath the 4, 5 halves plus or minus 4i over 2. You could even go in terms of this one, 5 halves plus or minus 2i. You could simplify this. So there is really about 3 different ways to write this. Alright. So then we come to solving quadratics by completing the square. Alright, so in this one right here, remember the first option in always solving quadratics is to look to see if we can solve it algebraically. If we can't solve it algebraically, then we look to see if we can complete the square, or if the numbers work to complete the square. So here we have m squared minus 7m minus 1 equals 0. Also, I want to look to factor. I want to look to solve algebraically first. I want to look to factor it and solve. If those two don't work, now I'm going to complete the square. So the first thing I do here is I move the 1 over. So now I have m squared minus 7m equals 1. I now take half of the middle term. So half of 7 is 7 halves, and then I square it. Squaring 7 halves, I get 49 fourths. So let me go through that again. Completing the square is taking the middle term, the middle coefficient, taking half of it, and then squaring it. Now the thing I got to realize is that in algebra, if I add 49 fourths to one side, I got to add 49 fourths to the other side. So now what happens is I change this 1 to be 4 fourths just by multiplying by 4 over 4. Add these together, I get 53 fourths. To get my square, I take the square root of the first term, square root of m squared is m, keep the middle sign, take the square root of the last term. Square root of 49 is 7, square root of 4 is 2 on the bottom, parentheses, I've got m minus 7 halves squared. That means that if I took m minus 7 halves times m minus 7 halves, I would get m squared minus 7m plus 49 fourths. Now, if you see, I can solve the problem algebraically. I take the square root of both sides. I get m minus 7 halves plus or minus square root of 53 over 2. Remember, square root of 4 is 2. I then add the 7 halves to both sides. Now I have 7 halves plus or minus square root of 53 over 2. Now this one is a difficult one because not only are we going to have to do something when we complete the square, but we're also going to deal with imaginary numbers. In the first example we did, notice that the coefficient in front of m squared is 1. In order to complete the square, the coefficient in front of m squared must always be 1 before I do the process. So on this one right here, First thing we do is subtract the 8 over. So the 8 here was subtracted over. Now we find ourselves with a different coefficient in front of the x squared besides 1. So what we have to do is factor it out so we get a 1. So essentially what we do is divide by negative 9 by 3, divide 3 by 3, that gives us 1, that gives us negative 3. Now we're set up to complete the square. Take half of the middle term, negative 3 halves, square it, we get 9/4. Remember, when I do to one side, I must do to the other side. But I didn't just add 9/4 to this side. I added 3 times 9/4, which is 27/4. Let me say that again. I added 9/4 to the trinomial, but I didn't just add 9/4 to the whole side. We're concerned with the whole side. So if I distribute this 3 here, I get 27/4, so I must add 27/4 here. Adding these two together, I get negative 5/4. Also, let me show you how I changed negative 8 to negative 32/4. All I did was realize I want 4 on the bottom, so I multiply 1 by 4. If I multiply the bottom by 4, I got to multiply the top by 4. That gives me 32/4. That's how I got that negative 32/4. But when I add these two together here, okay, I then get negative 5/4. Remember, square root of the first term, keep the middle sign, square root of the last term. That's how we get this. Then what I do is I want to get rid of the 3 first. So I multiply by 1/3 on this side and 1/3 on this side. I get x minus 3 halves squared equals negative 5/12. I'm then going to take the square root of both sides. Okay? So when I take the square root of both sides, again, look at this. Square root of negative 5/12. I take the I outside and I have I square root of 5. Simplify the square root of 12. 4 times 3. Square root of 4 is 2, so it becomes 2 square root of 3. Now I have to rationalize the denominator. So I have to multiply top and bottom by square root of 3. That's how I get I square root of 15 over 6. Okay? Now, so that's how I got I squared root of 15 over 6. Now the only thing left to do is to add the 3 halves to both sides, and we get 3 halves plus or minus I squared root of 15 over 6. Remember, you can write this as combined, or like we did over here in the first example, you can separate them and write them in the A plus BI form.